Primero.
Okay. Okay, so I'll start. Imagine that you are working in a small medium company. They produce metal parts with CNC, and they have a problem because they need to optimize their production. They need to produce more in less time. Right now, their cycle time for the CNC, they're producing the same part, is 12 minutes. And so the CNC is producing a part in 12 minutes. But they have only one worker. And but they got an investment so they can automate part of the process. They have 6 CNCs, one worker, and a cycle time of 12 minutes. How would you optimize and organize that layout? Imagine that it's a house mini meal. They have 6 house mini meals. How would you prepare the layout? How would you define which kind of robot, PLC, HMI, and everything? How would you decide what are the possible components for this?
Okay. So if they have 6 CNCs, I will put them all in line. At the back, I will use one robot with I don't know how to call it, the movement, so you can move like across the 6 of them. One conveyor going to the an automated like shelf, like the one we used in the processing unit, and well, basically, I will use maybe a Fanuc since it is the most simple robot. I think it's the one that will give less problems. And yeah, so basically, also, so the 6 CNCs, the robot moving, a conveyor, and the automated storage. And eliminate the operator, the PLC. I would use a singular PLC, maybe an Allen Bradley to control everything. Enough inputs and outputs for with one modular tarjeta, a board. And yeah, you just need the sensors for the for when the piece arrives in the conveyor and when it reaches the final part, so the automated storage can start to work. And you need a signal that goes from the CNC to the robot so that it knows when it finishes a piece, and it can translate it from the open the door and move from the CNC to the conveyor.
So my next question would be, well, what should be the cycle time to get the part inside of the CNC and take it outside?
The operator putting the piece or total time?
What should be the cycle time for getting the part inside of the machine and take it outside? Since you have 6 machines and the cycle time for each machine will be 12 minutes.
I'm not understanding. So
So
putting the piece, machining the piece, and putting it on the conveyor. Total time of that.
But the cycle time of putting the part and getting outside of the scene, what should be the cycle time for each one? Those operations.
Well, it has to be the same as the limits that you have to establish. If it's 12, it has to be 12. And you can vary the CNC's cutting speed or the cutting speed, spindle speed, and feed rate to match those times.
And how you're gonna balance the load each one of the workstations?
Well, you can put it not necessarily. You can put it if you program it for with proximity sensors or with something that establishes when you put something inside the CNC. It doesn't need to be like it has to be in order or something. It just
Then I'm gonna turn on the machines, all of them. And this is an important question.
okay.
Should I start the G code in each one of them at the same time?
No, there has to be an offset, but it can be at the same time. It can be at the same time, but better to have an offset so that the robot knows better in which direction it will go, and you can establish the trajectory that it will follow.
But in terms of time, having all the CNCs ending at the same time, is that correct?
Because
Imagine
if
that
if
you have
because
to take all the parts at the same time, you will have time.
because if you put the CNCs at the same time, you will have six complete pieces when the cycle is done. If you put them with an offset, you will have like one, and then you'll have to wait another 12 minutes for the other one, another 12 minutes for the other one, and now you will have a larger spacing between them. So I think it's better to put them maybe at the same time.
Are you sure? Because you will have downtime when the machines are not ready, because then you have to put again material.
It's just one batch, or how many batches?
No, it's full production all day. 3 shifts.
All production all day. Well, yeah, maybe separate them into two, and just with offsets in between them, and that's it.
Why?
Because when one is done, you immediately put the other one in, but the robot will be also finishing another set of materials, so you won't be able to refill the CNC machines. So you have to like separate them so you can enter safely the process, but also reduce the cycle time.
So, and what's the main philosophy that is behind of that?
In which aspect?
On having the same load distributed.
So there's no downtime.
Yes, but what's the philosophy that we are using to get that type of balance in the manufacturing itself? The philosophy, the methodology behind the value stream map, or behind everything.
I don't know, the ISO,
No, the method, what's behind,
the 5S, or
but what's the main thing that is using 5S and value stream just in time, 7 ways.
don't
The
remember the
main
name.
concept is manufacturing. Okay.
Lean manufacturing
And what's the main idea of the lean manufacturing?
to, well, make it all even and
Okay, so the next 5 questions will be short answers, so please be prepared. Okay, what's the G code line used to have a rapid movement?
G0, G00,
Absolute,
G90,
metric,
G20,
X, Y, 20,
G17,
and encode for activate the cooling?
MO8,
How you will change a tool in the CNC
MO6T, and the number of the.
and how you are gonna put it in the CNC? What are gonna be the clicks?
So erase the already line, put MO6T and an empty one. Click on the tool, put it, and then change the last T to the one of the slots.
In the G54, what's the value that we should have in Z?
0,
What?
because it's the well 54. Isn't it from 54 to 59 the ones that we can change? So then it will hit the piece if you don't put it correct.
Sure, I'm done.
Okay, let me ask. In your station, for example, you have two types of connectivity, point-to-point and communication between the sensors, actuators, PLCs, robots, etc. So, what are the main difference in consideration between these two types?
You mean protocols and the point-to-point? Or
Yeah, or communications.
well, us, we use point-to-point. It's just basically goes directly from the sensor or the actuator to the inputs or outputs of the PLC. And contrary to most of the Fred factory, which uses, I think, Modbus, which uses a special type of cable to connect the sensors, the actuators, and everything else to the PLC. But in our case, in both of them, we use point-to-point. So all our sensors and actuators are connected directly to the PLC point-to-point. The ones that need to be connected to the Siemens PLC, also point-to-point, and well, just the HMI with Ethernet.
And what devices that you use communication?
In what way?
What devices that you use in your station for communication in order to exchange data between two devices?
It's just point-to-point and one output from the of the output module.
You don't use communication. What?
We use Ethernet and a switch, but that's for the computer and the HMI. Just so it's Ethernet IP for in that case, but in between them it's point-to-point.
When you are selecting a robot, a PLC, in order to integrate the process, what consideration or specifications, technical specifications, you need to consider in this case to work to integrate these two devices?
So in our case, for example, we have the KUKA, but there's an adapter or something you can buy external from the like an add-on for the robot if in order to use a communications protocol, so you can connect the KUKA to the directly with Profinet or another communication protocol directly to the PLC and just use that one cable. So you need to see those specifications if the communication protocol you're actually using is compatible with the robot you're going to use. If not, you can always use point-to-point like we did, but it will require more modules for inputs and outputs.
Okay, imagine that you have you need to add a conveyor in your station, but with this driven by a AC model. What do you need to consider in order to integrate a control with PLC?
Okay, so if we're adding a conveyor and it is in, okay, so firstly we will have to change the setup that we have so that the conveyor will be like well positioned for the reach of the robot. Then, well, for the physical connections, what type of conveyor is it?
That is driven by a AC model.
Okay, so for the AC motor, you always need a driver. So you need to connect you need to connect the driver to the, like, configure it. And then the conveyor, you need to do it like the connections to the PLC so that it will know when to start and when to stop. And well, the sensor needed when the piece is put on. And we'll maybe use a communications protocol if you're, well, in our case, we could not, but if you have everything already connected, the simple Profinet.
Okay, so finally, the last question will be, from your experience in the Bread Factory Challenge, what's the new knowledge or what are the new things that you value the most in your point of view from the challenge?
In my perspective, maybe knowing how to handle different personalities was something that I take from the project. Communication, I learned that it is key and I know that this project, it resembles the real life scenarios. So I think that it will help me a lot for when I have to do it myself in the industry. And also the integration of everything, just watching everything that we've learned from HMIs, PLCs, robot, everything just combined into one thing. Well, it's like the only place that we were able to do this. So yeah, just integrating everything was great.
Thank you, Ricardo.